Okay, so now what we're going to do is move on to our present value of a single amount. Earlier we were able to calculate the future value of a single amount. Now we're going to take that information and calculate the present value of a single amount. And basically it's the exact opposite, guys. We, at this point, understand how much we need to have in the future. What we don't understand, what the unknown is how much we need to invest now. So that's what's actually happening. And remember we said that with the future value, what happens is the interest compounds. It grows on top of another, right? But the opposite effect happens when you're trying to calculate the present value of something, okay? The interest is actually being discounted. That's the key word, discounted. And so it has the same effect as compounding, just in an inverse relationship, okay? And so now we're going to identify how much we need to have if we trying to make a purchase or if we trying to have a certain amount in the future. So it could be useful for retirement. It could be useful for big purchases like a house or a very expensive car. Present value takes care of all of that, okay? And so let's look at the present value. So I'm going to, again, work through some problems. And I'm going to give you some present value figures. And this time they're already giving us the future value. So we have 20,000. And we'll do 2. We have 14,000. You still always need an interest rate. So our interest rate is going to be 7% and 8%. Okay? And we always need the time, right? Number of years. We always need the time, number of years. And we have 10 and 12. Perfect. Okay? So, formula. Let's go with the formula. If we use some algebra, we could easily find out what the present value is, right? Because we know how to calculate the present value, right? So the present value would simply be the future value divided by 1 plus the interest rate to the nth power. And again, we already know what those variables mean at this point. So we could go ahead and apply this formula to calculate our present value. So, $20,000 is going to be the future value for the first example. And the interest rate is 7, so 0.07 to the 10th power. And this is going to tell us how much is actually the current value for this amount. And to be honest with you guys, for accounting purposes, you will be utilizing the present value, because sometimes you have to find the present value of things in order for financial reporting of certain types of assets. Even on the finance side, we evaluate our assets based on the present value. So this is one that you need to really understand and be familiar with. Alright, so we're going to find the interest factor first because it's the auto operations. And we're going to raise that to the 10th power. And I have a number of 1.96715. And I'm going to divide that into $20,000. And I'm going to take $20,000, divide it into 1.96715. And I'm going to get a number of 10,166.99. And basically what we're saying is, if you wanted to have $20,000 10 years out, if you had an interest rate of 7% being compounded, how much would you have to invest now, right? How much would you have to invest now? And the correct answer would be you would have to invest $10,166, roughly $10,167, okay? So, again, let's go back to the chart. Now, we're going right in the back again, but we won't use the same chart. Why not? Because that first chart, the first table, represented the actual future value of a single amount. And now we're more so want to consider the present value of a single amount. Okay? And so, in terms of calculating the present value of a single amount, the rule still applies with the appendix table. You have your columns that represent the percent and the rows that represent the years. So what we would do is find the column that represents 7%. So we'll look at the 7% interest column, and we'll look at the row that represents 10 years. So we have 7%, 10 years, and I have a number of 0.50835. Interest factor 0.50835. 5. And what am I going to do with this? I'm not going to divide it. I'm going to continue the simple process of multiplying. So I'll multiply the future value times that, and that will give us my present value. Almost identical to the previous calculation, right? The old school calculation. Again, you may have some variance, and that'll be strictly due to rounding errors. And we get some 10,167. Very easy, guys. Very easy. Okay? We can quickly do another one right quick. I think you guys should be comfortable with this. Honestly, I really think you guys are comfortable with this. We're not going to waste any time on that. So this is enough for you all. Watch this over, but this is the present value.